If you love space science and astronomy news, check out my 60-second short videos every weekday. In case you missed them, here's all the daily videos in one cut. There was a ton of great stories this week, but of course there's a ton more out there just waiting for you to discover them on your own. Please follow, drop a like, and consider subscribing on YouTube to support the channel and so you don't miss another space science update. Black holes are fascinating and mysterious objects, and astronomers are finding new ways to study them. The Event Horizon Telescope is an international network of radio telescopes that create a virtual dish that, through a technique called very long baseline interferometry, is in some ways the diameter of the Earth. By combining EHT data with observatories at other wavelengths, both on Earth and in space, astronomers have been able to get their best look yet at the supermassive black hole at the heart of the elliptical galaxy M87. M87's black hole is a whopping 5.4 billion solar masses. The researchers want to study the physics happening around the black hole and figure out how particles get accelerated to near light speed in jets that erupt from black holes periodically. This will also give us clues to the origins of high-energy cosmic rays observed here on Earth. One such high-energy jet was observed from M87 in 2018, and the EHT team published the results in the journal Astronomy and Astrophysics on Friday. Citizen science projects are an amazing way for volunteer members of the community to make significant contributions to scientific investigations. Often full-time researchers don't have the resources to gather all the data they need, and that's where citizen scientists make a big impact. A great example is an effort to map the effect of geomagnetic storms on the ionosphere. In addition to the visible aurora, researchers are interested in measuring the level of ionization and the total electron content of the ionosphere during these events. Citizen scientists were able to contribute their observations of the aurora during the storm. This was combined with satellite data obtained by MIT Haystack Observatory researchers, and the results of the study were published in the journal Geophysical Research Letters. As we saw the other day, geomagnetic storms can have a big impact on satellite systems like GPS and the machinery that relies on them for location data. It's super cool to see full-time researchers and citizen scientists collaborating to generate useful research. A quick internet search will show you there's a ton of opportunities for citizen science out there, so take a look. NASA announced yesterday that astronauts Suni Williams and Butch Wilmore will be spending at least an additional month on the ISS, adding to their already extended stay and bringing them back to Earth in late March. SpaceX is slightly behind in completing a brand new Crew Dragon capsule that will carry the Crew 10 mission to the ISS. Crew 10 will replace the 4 astronauts of Crew 9, including Wilmore and Williams. While they originally expected to be off the planet for just 10 days, the delay will bring Wilmore and Williams' time in space to around 9 months, after issues with their Boeing Starliner capsule meant they could not use it for the planned return trip. Although it's longer than expected, the time in space is not that unusual, with multiple humans having spent around a year or more continuously on orbit. Speaking of SpaceX, the company managed 3 launches, 2 from Florida and 1 from California, and the successful landing of a cargo Dragon capsule, all in the space of 22 hours over Monday and Tuesday. SpaceX has now completed 128 launches this year without counting the Starship test flights. As the race to build permanent bases on the moon intensifies, one key resource will be the water that's essential for sustaining human life. Until recently, it wasn't clear there was water on the moon, but in 2008, scientists were able to measure water in Apollo 17 lunar samples, and several spacecraft have now detected lunar surface water. The origins of water on the moon are a hotly debated topic, but new research has studied the isotopic composition of water in multiple samples from the Apollo 9 mission. The research finds that there are 2 sources of water on the moon. The first is water that dates from the time the moon formed and is the same as that found on Earth. A second source of water has been delivered by ice and comets that have impacted the moon since it formed. The researchers are able to tell the 2 sources apart because their isotopic signatures are different. Understanding the origins of this water is not just an interesting question for fundamental science, it will inform decisions on the best places to look for significant sources of water on the moon and has implications for understanding the origins of water on other bodies in the solar system. If you're not a fan of salad, space travel may not be for you. A cool article over at the NASA website has details of various studies trying to figure out the best way to grow food in space. Transporting enough food for long-duration missions is not practical, and stored foods can lose nutritional value. Growing space gardens may be a good solution for a number of reasons. It's known that tending a garden can have positive psychological effects on astronauts, and the plants also produce oxygen and reduce carbon dioxide. The ongoing studies have looked at different aspects of growing plants like lettuce and cress in space. Varying levels of water, gravity, fertilizer, and a range of different lighting schemes have been tested. Scientists have even looked at the genetic changes induced in the plants by the varying conditions. Researchers have also been using experiments on plants aboard the ISS for years to study some of these issues. All of this will help provide solutions to the problem of feeding astronauts healthy and nutritious food for months at a time as we think about long-duration missions to the moon and beyond.